Today we're starting Chapter 8, Database Application Development. This chapter is a little special. That's why I pushed it back to week 13, and we're going to spend at least a week and a half looking at this chapter. First of all, not all the editions of the textbook included database application development, and for a good reason. Cramming all this into one chapter is very difficult, and for a long time the authors abstained from doing this, which was good. Now, what they have done in this chapter is what all textbooks on databases do. They mixed up quite a lot of topics, and this chapter could easily be a book. So I'll have to go slowly about it. At the same time, I knew that this would be happening, so we have looked at some of these topics several times throughout the semester, and I hope most of you can recall the conversations about clients and servers, about mainframe computers, thin clients, thick clients. Of course, we talked about the internet and the differences between the internet and the World Wide Web. So we are going to go slowly and we'll review some of the topics we've already covered as we look at the slides. Of course, we always start with term definitions, and slowly we'll try to make sense of this large number of programming languages which many of you have not yet tried. A big deal to mention here on this slide, slide 2, is that connecting databases to other applications is a special topic, and database connectors could take up a whole book. So I have planned an exercise in which we will attempt to connect MySQL to one of the APIs we will develop, but once again, that's going to be stretched across a couple of weeks. So if you've never tried Visual Basic, here VB.NET is the current blend of BASIC. And if you've never tried Java, which is a very large collection of tools, Java is an infrastructure language, and it's a very large topic. So if you've never tried that, don't be discouraged. I'll make sure the minimum that you need to know, you will know, and the rest of it will be up to you to discover after the course. We will look at PHP. We'll look at most of these acronyms that are shown on this slide. And of course, we'll talk quite a lot about client-server architecture, and I'll make sure that your experience with MySQL that you have gained over the past 10 weeks will serve you very well in this chapter. And when we start looking at the terminology when it comes to clients and servers, you will be asked to go straight to your installation and discover that not every client and server architecture involves two different computers, two different physical hosts. And that's unfortunately what every single book usually covers, and they always neglect to look at the software servers. That's exactly what you've been using with MySQL, SQL Plus, and of course with Microsoft Access. So networked computing model has been discussed, and you know my definition of a network that we use in this class. We're going to look at the definitions which involve clients, servers, workstations, hosts. You will hear that all servers are hosts, but not all hosts are servers. We'll revisit the whole history of mainframes and how we ended up with computers on our desktops. And of course, we'll look at the internet as the driver of the database technologies which have penetrated the corporate networks. You have also heard this more than once in class. The portion of the chapter to which this slide refers jumps straight into the internet computing. That, of course, needs to be explained, and that explanation is that for the past 25 years, the database technologies developed for the internet became the dominant type adopted by most companies. Historically, the size of computers has been decreasing. From mainframes, the mini computers were developed. Then microcomputers, approaching the size of personal computer, those were in demand throughout the 1970s, 1980s. And then the personal computers became the dominant type of computing when user maturity became high enough for practically every business to computerize. Not all the personal computers which landed on the desktops of the users were networked. In fact, for a very long time, networking personal computers was a very special and a very expensive project. Sooner or later, that had to happen. The computing needs of a business would grow over time. The number of computers would become so high that they would require their own room. The room would grow into a farm, and then we discussed the need to have a data center as part of the IT operations of a medium-sized or a large company. That's where the servers are housed. And this is the moment when we need to start paying attention to what a server is. But before we do that, we'll look at this slide, which takes us into that part of terminology which deals with a layered representation of computing environments. And that's when I need to pause and make sure the layering is explained, at least in a basic way, before we go any further. Now, an important reminder here is due, and that's the application you've already experienced in this course. If you go back to the second week when I asked you to work on the Department of Transportation access file, you used the form for making new entries into the database. That was a very first experience for some of you with a database application. So we could go straight to the table and start entering the data manually, or we could go to the form and start entering data also manually, but in a more organized, more controlled way, without looking at the entire table. So that was the precursor to today's topic. So you already know approximately what a typical database application would look like. And once again, in case of Microsoft Access, it runs from your local disk. The server in this case would be a software server, and the client, such as this, the form, would be running on the same local machine. As you can see here on slide 9, both servers and clients are hosts, so there isn't much explanation of the situation we've been using the whole semester, and the book would imply the use of the same arrangement with SQL+. We have a host for the database server right here. We have a host for the database client, and these connections with one another, which we basically have to imagine. Since we don't have a lab in which we can practice, most schools wouldn't, the setup of a client-server data exchange, I'll have to use a typical training software which will allow people who have never heard about client-server data exchange before this class to visualize easier what's happening between the clients and the servers when they're hosts. By this time, I hope you have finished part 3 of homework 3 and you know a little bit what markup is required for an application in the form of HTML tags to format the user interface, which is one of the most important database applications, in a way that will be very usable to the user. Okay, what we're going to do now, just create a very simple connection. Get a host for the client, get a host for the server. Now, since this is a computer-to-computer connection, in real life quite a lot of other devices would be required, which we're going to skip right now. A router defines a network, and behind the router, the connections in a normal business would be accomplished by the services of a switch. But we'll skip it now and we'll use what is called a crossover cable when there is no switch involved. The crossover cable is required. This will illustrate the crossover connection easily. As you can imagine, in a telephone receiver, this is the speaker and this is the microphone. The speaker and the microphone. So for this speaker to work, a connection to the microphone is required. Likewise, for the other speaker to work, the connection to the opposite microphone is required. And this is what creates the crossover connection, which we'll be using, which I already have used in a packet tracer. That's why this cable needs to be special. Now, the modern network operating systems account for these connections, and theoretically this will not be necessary in a real production corporate environment. But to model the connection in packet tracer, I certainly must use a crossover cable. Next, for this connection we need to assign IP addresses. We'll address this topic in a little while, so for those who are not exactly familiar, I'm sure all of you have heard of IP addresses. Many of you probably check the IP address on your machines. For those who don't do this, just bear with me. I'll create an explanation for this a little later. Okay, we'll just use a typical C class address. This is the subnet which will appear automatically with this type of address. And for the server, we'll use a different number. We'll have 3 here, and that's about it. As usual, usual for those who do this periodically, we need to make sure the connection is working, although the green lights showed that the connection is live. So we'll just use the ping command as an important step here. So we have 4 replies, no loss. So we have checked the connection. We can now use this host to link to the server. Okay, so this is an emulator of a browser, which is the most important database application that we use every day. And when I just click and go, we get to this server, which has a little website with 4 little pages. Since they're a little bit boring for us, let me just do something that you're already familiar with, and that was the purpose of part 3 of homework 3, just to introduce you to markup, to the connections over the network, which will allow the user to view the files stored remotely. Hopefully this will be a bit more fun experience. Hope this looks familiar. Okay, we get Cisco logo here. This software will not allow to use any images that are not approved by Cisco. This is part of their marketing, although it was tempting to put the university logo here. Of course, I will not be allowed to do that. And you can look at what other things they have. Yeah, this is my attempt to put a different logo there. Okay, so now you see how we are accessing this host, which is the server, over a network connection from this client, PC0. This is the situation in which both end devices are hardware devices. For those of you who understand that we need to put in a lot more, like switches, for example, I have a different video that will show you how to configure. You want to play with this, I have put an installation file for this version of the Cisco Packet Tracer on my Google Drive, and there is an exercise for those who are interested that will require a PDF file, which I also have for you, and it'll be found there as well. So I used to teach Cisco training in a different school, and that's the material from that design. So I know this was very important to those folks in that setting who knew a little about this. So I'll use that previously designed material for this class as well. So we've now looked at the physical connection between the two hosts, one of which is a physical server and another is a physical client. However, when you installed MySQL on your machine, the directory in which it was installed was named MySQL Server. But your interaction with that server would start with the Start button by clicking on MySQL command line client, and there is no directory in the MySQL install which says MySQL client. So for this particular arrangement, both the client and the server are located on the same disk. So in the next few seconds, I will let you recall the dialog boxes that MySQL uses during the installation process. And you will see that all the server files and the table spaces for the database engine called InnoDB are going on the local disk, the C disk, which is a great occasion to introduce the concept of local host. We will briefly talk about local hosts probably next week, but I'll let this finish. So once again, the point to make here that in this exercise that we have just performed, all the content that was available to us through the browser was typed in by hand into that HTML file. This was not, none of this was fetched over the network from a table on that server, converted into an HTML, XML, or an XHTML file. That was already typed in by hand. The trick is to have an arrangement in which all these characters, all this content actually appears in front of your eyes because it was fetched from a table or a query in a relational database residing on that server. If you can recall the authors table from our database called My Own Amazon, that would be something of the shape of this particular interface, and that would come from an important server-side database application called phpMyAdmin, which is actually mentioned in the slides here. Right over here, that's in slide 2. So now that we're moving towards the topic of a layered representation of computing technology, I really need to remind you about the layered model I briefly mentioned in the beginning of the course. That was the TCP/IP model, and its European counterpart, which was created by the International Standards Organization, ISO, later in the history of networking, called the OSI model, Open System Interconnect model. So on this slide, we revisit the definition of a computer network, mentioned several times during my lectures. This was for those students in that class. I think it could be useful for you as well. The differences between the parts we did not put in that packet tracer model, but it will be shown in the video only for those who are curious. That video I keep mentioning will not be needed to the majority of the students in this class, but I just want to make sure there's always somebody in the class that has some networking experience, has some database experience, and these nuances should be shown to the people who will definitely have questions about this. So we have hubs, switches, and of course routers. And we've been discussing the physical components as opposed to logical components. Network topology is an important topic we don't have the time for. Of course, we just had a two-node connection in our model. And here comes the layered representation of the networking technology over which the databases are deployed. Quite a lot of slides and pages mention the word protocol without really explaining what that is. Protocols are rules. In our cases, those are rules of communication between the nodes or hosts or the end devices. Deep down, these protocols are really important to those who design physical circuitry that is inside every computer. The frequencies with which those parts generate their signals are determined by these rules we call protocols. That is beyond the point. We don't have any room for discussing electronics in this course, although I couldn't help bringing up the topic of crossover connection. Okay. So once again, the client-server model in our case will be between two physical devices. That would be the situation in which one device requests the data and the other device supplies the data. We know the typical way in which data becomes information. In these slides, that is used interchangeably. Here come the layers in the TCP/IP model. It has 4 layers. We start with network access. We actually, in this case, will be moving from right to left. Network access, internet, transport, and application layer. That's what is used by the user, and that's when all these database applications become important. Once again, for our case, when we use MySQL, the database application is that client, the command line client, MySQL client, which we used to enter our commands. Select everything from this and that table, show databases, show tables, source, if you can recall. I don't need to name all the commands we have covered in this course, although I do hope, let me just go on a tangent for a second, if you've done everything I've asked you so far, by the end of the semester you will have written at least 100 queries, and that covers the basic SQL training. In this slide you see the comparison of the two models. The one that has 7 layers, once again we're talking about layered representation of technology. That's the OSI model, that's from the European Union. The TCP/IP model is the American model, which came out a little earlier, has 4 layers, doesn't really account for color. However, when we start connecting the two nodes, the two devices, the OSI model breaks down. you'll see that we'll have to go back to the network layer when we have to connect the devices. So TCP/IP holds, and OSI is mostly used for training, and in many cases by salespeople. It's a very useful model, but it cannot exist without the TCP/IP. So these two models are always used together. So the layers are physical in the OSI model, physical data link, network, transport, session presentation, application layer. For physical layer, just picture the cables. For data link, if you've ever inserted a network card in your machine, that would be the physical component to picture. Network layer, layer 3, that's where the routers work. So data link is for the switches, and the network layer is for the routers, and that's where it all stops for a second. Just look at the 7 and 4 layers, which are basically the groups of electronic devices which work inside every computer. And as you can recall, those electronic devices have to be coordinated by this important thing called the operating system. We talked about this in our lectures. So we're looking at the application layer because it's most important for the interaction of the database user with the database applications. I'll quickly click through these slides, and then we'll start talking again about client and server data exchange. So this is the list of the protocols which run on the application layer of the TCP/IP model. Let me just slowly click through these, but I will not talk too much about it, just for the sake of saving time. At the end, we look at the application and presentation layer of the OSI model, and in the TCP/IP it's combined. TCP/IP stands for Transmission Control Protocol IP Protocol. Once again, it's a collection of protocols called Protocol Suite, whole set of them. And that's where I was going with all this. So for our purposes, it's important to note on the left these cascading images. We'll go back to them at some point. We'll just use this cascading arrangement to demonstrate the layers of the applications on the server side. Next little piece of terminology. When the files are directed from server to the client, that process is called downloading. But of course the server will not send anything to the client until the client asks for files. That would involve a process of uploading data. For example, through the client, a user will have to log on to the server. That process will fall under the upload direction. So the client-server model continues to be representing the physical devices. And I will continue reminding us all that in our case, the whole notion of a local host is very important, because for the remainder of the semester, we will not be using two different physical hosts, one for server, one for client. We'll continue working off the hard disk. That's when it comes to our home exercises. Now that we have all created our Teradata accounts, that interaction with the database will look exactly like the one represented in this slide and in the slides that came from the Hofer book. That interaction with the help of the browser with the database remotely stored on the server, that is fairly represented by this image. So we have both images combined on this slide, and that's when the topic of HTML comes up. That's what we have done in the part 3 of homework 3 and in the little exercise in Packet Tracer. So we've looked at marking up or structuring the page called the form for a readable presentation of the material to the user. So the hypertext markup language that we have used works necessarily in conjunction with the hypertext transfer protocol. That's once again the requirement for both the client and the server to run the protocol, so the communication may take place between the two nodes that understand each other. Next reminder, when we talked about the quality of the strings, typing characters into the strings requires an absolute undivided attention from the user. Otherwise, one wrong character in the string will ruin the string. And that, of course, applies to the full path of every file that you will use from now on. So HTML necessarily works with HTTP. Here's a little story of how a web page opens in the browser. Once again, the request comes from the client through all other devices hidden by this little cloud. The packets will get into packets in a couple of days. They reach the server, the HTTP server, and the server starts processing the request. Once again, based on the assumption that the request is understood.